This week we're going to work on solving stoichiometry problems. And so what we're going to do now is look at how the um, coefficients in our balanced chemical equations relate to the quantities that we're going to be dealing with. So up till now we've looked at a chemical equation, um, and the balancing simply indicates the number of those particular molecules or atoms that we're dealing with in the reaction. Well, those kinds of quantities are too small for us to measure. And so when we use measurable quantities, we're using moles of substances, right? That really big number. Um, and so what we can do now, because it's just a difference in a factor of 6.022 times 10 to the 23, we can convert those to mole ratios. And so mole ratio indicates that same relationship, only now it's in a measurable quantity. So here's an example with iron and chlorine to make iron 3 chloride. And as I said before, we previously talked about it as being for every one iron and one chlorine molecule, I can make one iron 3 chloride molecule. Well, that doesn't quite work because, of course, this chemical reaction isn't balanced. So that's the first thing that we have to do. So we have to balance this. So when we balance this, we get for every 2 irons and 3 chlorines, we can make 2 iron 3 chlorides. That's kind of how that works. If I take, for example, in what I've got here on the screen, 150 atoms of iron, and I react it with unlimited chlorine, how many molecules of iron 3 chloride am I going to make? Well, it's a 2 to 2 ratio. So for every 2 irons, I make 2 iron 3 chlorides. So if I have 150 atoms, I'm going to make 150 atoms of iron 3 chloride. Fairly straightforward. Now, if I change that to a measurable quantity, like 2.75 moles of iron, the same sort of principle applies. So for if I have 2.75 moles of iron, I'm going to get 2.75 moles of iron 3 chloride. So when we work these reactions out and we try to figure out the number of moles, the way we generally work this through then is we first of all have to balance the equation. If we have a number of atoms, we have to convert that to the number of moles because it's a mole ratio. We convert those moles then to the given moles of the unknown using the mole ratio. And then we can convert back to either the number of molecules or the mass. So here's an example. For the reaction below, what mass of oxygen is required to consume 6.8 grams of ammonia? So here's the reaction. Ammonia and oxygen gives us nitrogen monoxide and water. Balancing it, we get 4 ammonias, 5 oxygens, 4 nitrogen monoxides, and 6 waters. All right, so the number of moles then of the ammonia, given that we have 6.80 grams of ammonia, divide by the molar mass. So remember, molar mass, we just use our periodic table to figure that out. The molar mass for nitrogen plus 3 hydrogens, and then that gives us 17.04 grams per mole. Do the math, and again, remember to leave these numbers in your calculator the way they are. Use your memory locations. Go back to the video that I did on calculator memories to help you with that if you need to. Then we figure out the number of moles of ammonia. For oxygen, sorry, it's the ratio for the oxygen here. There are a couple of ways to do this. Your textbook does it one way, and have a look through those examples. This is the way I would have taught you in class, where we use the moles of what we're looking for divided by the moles of what we are coming from. In other words, the number we're using in the calculation. So the number of moles then of oxygen is going to depend on the number of moles of ammonia times the mole ratio of oxygen to ammonia is 5 to 4. 5 to 4. So that gives us this many moles of oxygen. And so the number of moles of oxygen, then the mass after we're done that, is equal to the number of moles times the molar mass of oxygen. And that'll work out to 15.962441 grams. Don't forget now we have to go back to 3 significant digits. Right, so this gets rounded to 16 grams of oxygen, 16.0 grams of oxygen. All right, we're going to leave it at that for this week because that's a lot of stuff to try and wrap your brain around. So there's the questions for this week. Give it a go. Come online, ask questions, either email me or put it on the discussion board, and make sure that you can do these types of questions. Okay, good luck.